Hi there, in this video I'm going to show you how to solve hyperbolic equations. Now I'm going to go through two cases, okay? So in this video we're going to be solving hyperbolic equations. So let me underline that. So there's going to be two cases that we'll go through. Okay, the first case is, so I'll call that case number 1. So case number 1 is whenever the coefficient of x, so coefficient means the term in front of x, so whenever the coefficient of x equals 1, okay, that means that we're going to be using the hyperbolic definitions in order to help us solve the equation in question. Okay, so let me just say coefficient of x equals 1. Okay, but not only the coefficient of x equals 1, whenever all of the powers in your equations are 1 also, so if the coefficient of x equals 1 and powers are 1 in equation, okay, that means, so that implies use hyperbolic definitions. Okay, so hyperbolic definitions refers to the definitions of, let's say, hyperbolic sine, hyperbolic cos, hyperbolic tan, etc. in terms of exponential functions in order to solve the equation in question. Okay, so we only do that if the coefficient of x in our equation equates to 1, and also if the powers in our equation is 1 also. Okay, so that's case number 1. So let me show you with the aid of an example. So example number 1. Example number 1 is to solve, and we're going to solve this equation here in part A. 4 hyperbolic sine x minus 3 hyperbolic cos x is equal to 5. Okay, so in this particular case, the coefficient of x in both terms is 1, okay, and the powers are 1 also. Okay, so remember, if the coefficient of x is 1 and if the powers are 1, that means we need to use the definitions only to help us solve this the equation in question. So remember, just as a side calculation, remember the definition of hyperbolic sine. Hyperbolic sine has the definition e to the x minus e to the minus x over 2. And remember the definition of hyperbolic cos, okay, that has the definition e to the x plus e to the minus x over 2. Okay, so we need to use these two definitions in this instant. So we'll call that, you can call that step number 1. So if we replace in our equation, we'll have 4 hyperbolic sine, which has the definition e to the x minus e to the minus x over 2, minus 3 hyperbolic cos, which has a definition e to the x plus e to the minus x over 2, which equates to 5 on the right hand side. Okay, now I'm going to get rid of this 2 in the denominator by multiplying throughout by 2. So if I multiply throughout by 2, I'm going to have 4 e to the x minus e to the minus x minus 3 e to the x plus e to the minus x is equal to 5 times 2 on the right, that is 10. Okay, and if we multiply the brackets, so if we expand further, we'll have 4 e to the x minus 4 e to the minus x minus 3 e to the x minus 3 e to the minus x is equal to 10. Okay, Now we can simplify that further, so simplifying further should give us 4e to the x minus 3e to the x, that is e to the x, minus 4e to the minus x minus 3e to the minus x, that is minus 7e to the minus x, that equates to 10 on the right. Okay, so in that case, let's continue. Now we don't like negative powers. Well, I certainly don't like negative powers. So to get rid of this negative power term, I'm going to multiply throughout by e to the power plus x. So if I multiply by e to the power plus x, I'll get e to the 2x. So remember, e to the x times e to the x is e to the 2x, minus 7. So as e to the x times e to the minus x is e to the 0, which is 1, that is equal to e to the x times 10, 10e to the x. Okay? Now if I rearrange this equation, we'll have e to the 2x, taking the term on the right to the left, minus 10e to the x, minus 7, that equates to 0. Okay? So that takes us to the second step. Let's call that step 2. Now step 2 is we need to solve, so I hope you can see that, we need to solve this equation. Okay, now e to the 2x, I could write that as e to the x squared. Okay, so by doing so I can make this equation a quadratic. So we'll have e to the x squared minus 10e to the x minus 7, that equates to 0. Okay, and I'm going to make it resemble a quadratic using a substitution. So I tend to use t. So let me continue on the reverse side. So if I let t equal e to the x, okay, so if I let t equal e to the x, I can make this a quadratic involving t. So we're going to have t squared minus, okay, 10t minus 7 is equal to 0. So minus 10t minus 7, that's equal to 0. Okay. Now we can't factorise this quadratic, we need to use the quadratic formula. So if you use your quadratic formula, you'll have two values of t. So either t is equal to 10.7, so that will be the first value, or using the formula t is equal to minus 0.66. Okay? So remember, bearing in mind these are the solutions for t, we need to calculate the solutions for x. So let's go back to the substitution that we used. So let's call this step number 3. So since t equals e to the x, so firstly let's work out the x solution when t is 10.7. So when t is equal to 10.7, e to the x will be 10.7, and if you take ln's or logs on both sides, x is ln 10.7. Okay, so that is roughly, so if we calculate that, so ln 10.7, okay, so let's see what we have. So you'll have 2.37. So that will be the one solution for x. Now, this negative solution for t won't work for us. Okay, so let me show you why it doesn't work. So when t is minus 0.66, if we use that, e to the x is minus 0.66, and if you take ln's on both sides or logs on both sides, it doesn't work. Okay, so ln does not exist for negative values, okay, so that value wouldn't work. So the t value of minus 0.66 wouldn't work. So all in all, you'd only have one solution for x, okay? So these are the steps. These are the steps in order to solve a hyperbolic equation of this type. So whenever the coefficient or the term in front of x is 1, and if the powers are 1s in your equation in question, that means only use the hyperbolic definition to solve the equation in question.